In the previous lecture, we looked at TCP/IP sockets, TCP/IP sockets, and how these can be used to implement a connection-oriented protocol for server-server client communication. In that, we had seen there is a server class, the my server in that example, which was listening to the socket, and whenever there is a request came, it was till then it was blocked, and once the request came, it initiates a thread, and that thread essentially handled the request from the client. So all the client's requests were handled in a separate thread, and then finally when everything is closed, it was closing the socket. In the thread, what we did, moreover that method also, this method, the server was trying to share the one data item stock with all the clients. It needed a synchronized method which essentially protected the access to that shared data by using a synchronized keyword. So only one date thread can access that data at a time. In the client class, in the client we also created the socket which with an address of the server and the port, and then the client went on sending the reading the data request, reading the data from the user's request from the user, and then sending it through the socket inputs through the socket output stream to the server. And after that, when the server has finished the request, and sent the result data, it read it from its input stream of the socket, and then it went on doing it until until it found that the data read is end, in which case it closed, it can close the connection and can close this the socket also. In the thread, what we did is that we essentially in the states run method, we really read the data from the socket's input stream, and then that is the here, and then after reading the quantity or amount to be supplied to the server to the client, it executed asked the update, the synchronized update method in the server to be executed, in which case the amount of quantity was reduced, and the message was sent to the client that the updation has been performed. And when the request received this signal end from the from the client, that is this request is finished, it just it close the socket, that is in the thread itself we close the socket, and the execution of the thread was finished. So this is an example which we did in the last lecture, in which we dealt with the connection oriented client server communication. As opposed to the TCP/IP sockets, the Java also supports what we call the datagram sockets. This type of protocols, datagram sockets, are used to implement what we call UDP/IP protocol. But UDP, in this case, the only problem is in UDP type of protocols is that there is no guarantee that once a packet will be definitely be received at the destination end. However, it is sent, but the receipt is not guaranteed, whereas in TCP, which ensures the receipt, is a more reliable type of connection protocol. The advantages and disadvantages of these type 2 protocols are discussed or have been discussed in the network courses. The type of communication that we will be implementing here, in this case, the server will try to will use a call called receive data from the client. Client will send it to the server, and once the server receives the data or data request from the client, it will process it and send the result back to the client. Now again we will use multi-threading, that is different threads to process the requests of the client, and let us see how that is being done in this with a simple example. In this case, what we do, we want that the server to read from a file and then sends it as a request from the client comes, it will read from a file and then sends the whatever read to this to the client. We can later on, I mean, if a more sophisticated server will probably read it from another database and get the after getting client's request and then send the result back to the client. Now in this example, what we are saying, say here, if you look at it, this is a server class. We are creating a public class, a Datagram server. I am given the name, and in which initially there is a string is initialized to my Datagram server, and now we create a new thread object. So here what we will do, will receive the process the requests of the client using a thread called Datagram server thread string and start. Start will initiate the start operation of the thread, the run operation of the thread. So now let us look at the Datagram server thread, which extends thread as before, and here we are creating a socket called Datagram socket. It is a class, is a type which is defined in Java, and this class, this is a Datagram socket class, has several methods associated with it. And here what we do, we create a simple socket called with a socket number with a port number 8085. So it creates a socket here, and after this, then the protected, then we declare two input and some one input and other variables. In this case, the buffered input we declared is a buffered reader which is input, which reads data from when the data from this file called my directory my file is read will be read into this buffered reader object input. So what our target is that when the client's requests come, it will read from this file and sends the data back to the client. So my directory, the file is my file. And then in the thread, this is the constructor, which is the super name, and then just prints this that we are opening the server, and then start, which will call the run method. Now let us look at the run methods of this server. What it will do, while no more data is some variable we are using, which is a boolean. It is not, that is while it is not, that is while it is true, that is not no more data. That is data is still there. Then what we will do, we will have to receive the request from the client. Now for that we must prepare a packet through in which the request from the client will be received, and this will be received in a buffer which is of size say 256 byte, and this is a method supported. We create a packet, and this one is supported in the new Datagram packet buffer length, which satisfies that what is the length of the buffer and how much where it will be read. And then we execute the call socket receive packets. Remind it, we had said that we have to receive from packet, so therefore this server what it will do, it will wait till the client's request is received, that is a packet data from the client is received. And after client's request is received, then it will have to it will check first of all that whether there is anything left in the input. If there is anything left, fine. If not, if it is done null, then it will just send a string that nothing to be sent. Else data will be it will execute a procedure called read from file, and the read from file will be a procedure which will be reading the data from the file, or the file in this example is my directory my file. Now after this, once the data is received, so the data will be received, then it will have to be converted into bytes, because we will send the data in terms of bytes, and then that will be stored into the buffer. Now one question comes that client has sent a request, but question is how does the server know where to send the send the data. So it must know from the client's address. And to do that, what is happening, each datagram packet when it is received will contain the address from where it is coming, and for that it supports a couple of methods in this class. And what is that? Here is a client address, is a packet dot get address. This is a method supported in the for the packet. So once a packet is received, this packet will contain the address of the client which has sent it. Now, so this packet will, when it is being received, it will contain the address of that is, this is an INET address. Mind it can be either a that 4 with the complete physical address, or it can be a domain name which can be resolved. And then integer client port, get port. Also we need to know the port number. So the packet port number also is not obtained. Now, so from here now you can see that this server is at the thread is actually finding out the address of the client, and then it will be sending the data back to that place. That is, it will be sending the reply to the client. So for that, it now creates a new datagram packet where this buffer in which it is already have the data value to be sent. Buffer length is known, client address is now known, and client port. So this will be sent, this packet, then socket, send packet. So here it received the data and from the client, and after analyzing the packet, it identified the address of the client and then sent the data back to the client. And if there is no more data is true, then you close the socket. Then let's look at the protected. This read from file. This method, what it is supposed to do is, if data value, it will be basically reading the data. Input is the, as we have declared earlier, is reading from the buffered input, buffered reader, in which it is reading from a file. And if the data value is null, then you just close the input, is nothing to be read, and then you set the no more data to be true, and otherwise, and send the data value equal to, this is the value it will be returned. So end of data file. And this is a very simple one. This method essentially reads from the file and sends the result back to the thread in this here, and that the data is later on converted in bytes and sent to the client. In the client side, on the other hand, what we will have to do is that in our communication, the client also has to send the data to the server, and then while sending the data to the server, it must know the address of the server, and and then after that it must be able to receive the data from the server. So for this, client also has a buffer in which it reads the data, and in this example what we did, we assume that the server machine name is provided as an argument 0 in the main program. So if you don't remember that the main has some arguments, can take arguments which is RS of type string, and in this, as a 0th element, we provide the name of the server machine. And then what it does, INET address it gets the INET address is a class, as I mentioned, in which it get by name. This is the method which is supported in this class. It gets in by name method. You get the name of the machine. For instance, like we had the names like it could be yahoo.com or iitkgp.arnetin and so on, and then it creates a socket. Now in this case the socket are of the which the client one, it can be any arbitrary socket, but it just needs one socket here, and then it creates a packet, new datagram packet, client buffer length, address and 8085. We assume that the server port number is 8085. So what it does, this client will send this packet to this address, where address is the actual address of the machine or the machine name, for instance, which is provided as a argument of the command line argument, the main function, and then it sends it to this port, and then socket send port. So the client now sends the request. In this case, client sends a request to the server, and when it receives a request from the server, note that when you create the packet, you are not giving your own address, but it will be automatically appended by when it is being sent with the address of the client. And as a consequence, the client, when the server, in the previous case we had seen that in the thread we have found out what is the address of the server was, or the client was. In this in the earlier in this example, here in this case the server reconstructed the address of the client from its packet. So here when the packet is being sent by the client, it will automatically appended by the address of itself, and as a consequence, when the server program we try to got the get address, will get the address of the client and get his port. Although we have not any specified any port, so whatever the port the client was socket client was connected to, the appropriate ports will be obtained. Now when the server sends a request, replies, in this case like in this diagram, what happens that client will get the new datagram packet, client buffer length. Now here it will receiving the packet. So at this stage, whatever the data the server has sent, it will be received, and this will be printed. String data receive new string packet dot get data, and similarly the data which can be printed, and after that socket can be closed. So this is a very simple scheme. Again, what is happening here, we are creating we are serving the request of the server of the client in multiple separate threads, and and in each thread we are reading from a file. In the thread we are reading from a file and handling client's requests. So this is how the datagram or what we call the datagram sockets are used in the Java environment. Again, the example given here is rather simple, but we can create more complicated type of servers. In fact, we can create a server which can read from a database after interpreting the client's comment, that is whatever the request client has sent through the socket, interpreting it properly and get the result from this local database server, and appropriately modifying the result, can send it back to the client. Now, as we have mentioned that Java supports communication among the different machines which can be over the net, and one of the most convenient way of specifying the address of the machines, or particularly in the internet environment, is through what we call the concept called the URL, or Uniform Resource Locator. This scheme allows us to specify the location of any file wherever it is in the internet, and then and also the type of protocol that is being used for locating it, or the type of the for locating it. So there are different types of components of an ERLR, typically HTTP, which is hypertext text protocol. Then we have file transfer protocol, telnet, ways, gopher, etc. All these protocols components of an URL, and we can the other components are of the URL are that what is the domain name, like we had specified. The domain name can be IITKGP or net.in, or it can be a simple full-fledged IP address, like say for example either of them. It can be specified as a port to which it is connected, the directory path, that is which a file is located in which directory, and what is the name of the file, and there is another field called the reference files. Typically this approach is now frequently used in specifying the locations of the file over the net. And typically a URL would be of this form, say HTTP, which is a hypertext protocol, and then we have this is the domain name, this is the port, this is the file directory, and this is a file. Now if we may omit the port number, it's not necessary always to give the port number, or we can say for example in Java environment, or suppose the separate constructors for creating a URL. So the my server, for example, is new URL is the location of the server. This is my server, which is specified as an uniform resource locator, and this is my HTTP server, and so it will have the pages will be in HTML language, written in HTML documents, that is hypertext marker language, that is documents prepared using HTML language. And this is again will be discussed in detail in the internet course, and therefore we can specify the URL by simply giving the string, or we can specify the URL in this manner, that is you specify the protocol, specify the domain name, port number, then the directory path. And Java, what it does, it also supports several methods on this URL class, so that for instance if you specify you want to know what is the protocol used, or which is the host name, what is the port number, what is the file, what is the type of reference, and so on. So now in the earlier case we had specified in terms of INET, we can specify it in the URL also for the locations of the server or the client. And therefore once we have an URL object, URL is also URL object. In this case for instance we want to read from an URL, and for that Java also supports several methods. For example, we are reading from an URL, we can say that buffered reader in, which is reading from my server open stream. So basically we are reading from the my server is a URL object, if you recall, and in this there is a method called open stream. So you want to read from a stream oriented data, and then reading it into an in which is a buffered reader. Similarly, if I want to write to a URL connection, we can do it with the help of URL connection XA is a type, and then in this class, this object X, first of all you open a connection. So whenever my server that's an URL object has a method called open connection, which opens a connection to the specified URL, and then once we have specified the open connections, we can get the read from that URL through that URL or we can write to the URL connection. So methods like get input stream or get output stream are as available with the URL connections class, and which can be used to read or write from a URL connection. So therefore, while implementing client servers, we can use the concept of URL, that is uniform resource locator, and for specifying the server or the and then you can read through that connections also. And so this is also another way of reading and writing data from machines which are located at the distant places in the network. So what transfers therefore is that Java in a sense is basically supports quite a bit of network oriented programming, and that is why one of the this is now becoming very popular in implementing the different implementing uh, different applications over the internet. And in the Java libraries, like say Java.net package contains several classes and class specifications and methods which help the user in implementing client server communication, or that is a communication among the machines which are connected over the net. And these machines can be specified, their address can be specified through an URL. And many of the recent, as we'll see later on when we talk about Java applets, now many of the browsers today or some of the internet applications, the Java is used for communicating about different machines over the net. So what we have achieved so far, therefore, in these last few lectures, is that with the help of Java threads and the Java sockets, it is very easy to implement the client server communications. And these kinds of communications often help if you have a threads, we can allow some concurrent job activities to be performed in that is activities which are really not dependent on each other, can be performed in separate threads, and the synchronization can be done with the help of synchronized methods. And again, the sockets concept very much help in establishing connection between the server and the client, and that and apart also in network and oriented environment, we can use even the URLs to specify the locations of the machines. INET address can be used to specify the address of the machines, but in this case URLs can be used to the read and write files from the different types of servers, and then we can also specify where the file is located, what are the and in a very convenient way, and what are the different types of protocols to be used for reading and writing. Like we had seen that we can use a FTP, or you can use a HTTP type of protocols, and which satisfies that what are the types of files are. And this is very uniform, that is, since it's very is now universal, is now becoming very much popular in internet programming. The Java usage also in internet network programming is increasing very much. We'll in another course which deals with the internet and internet programming, the usage of Java will be illustrated in much more detail.